All right, so now we're going to look at the last part of our parallel lines cut by transversal. All right, we're going to look at the last two categories of angles that we need to look at. All right, um, so you should be able to follow along in your the guided notes there. Okay, we've looked at supplementary angles, we've looked at vertical angles, and we've looked at alternate interior angles. And now we're going to look into the last two categories. I told y'all that there were two more. So the next one is going to be alternate. Let me get the right color here. Black. There we go. Alternate exterior angles. Alternate exterior angles. And they're similar to in name only, but they're similar. The idea is very similar to alternate interior angles. So the alternate exterior angle theorem, that's what it's called. The alternate exterior angle theorem states that the angles exterior to or outside of the parallel lines and on opposite sides of the transversal are congruent. All right? The alternate exterior angle theorem states that the angles exterior to or outside of the parallel lines and on opposite sides or alternate sides of the transversal are congruent. Okay? They're very similar to interior, but the difference is exterior and interior, right? So when we talked about interior, we said that's on the inside of the parallel lines, on the inside, in between the parallel lines. So when we say exterior, you think of the exterior of your house or the exterior fence or something like that, okay? So we're looking at the angles that are on the outside of the parallel lines. Okay, those are the exterior angles. And we've already talked about what alternate meant. It means opposing sides, right? So let's look at this now. Okay. So we have the same kind of drawing that we've been dealing with. All right. And so we already know, let's use some different colors here. We already know that 1 and 4 are vertical angles. And so are 2 and 3. I'm going to draw a line this way so we don't get confused. And then 5 and 8 are all vertical angles. And so are 7 and 6. Okay. And they're all congruent. 1 is congruent to 4, 2 is congruent to 3, 5 is congruent to 8, 7 is congruent to 6. Then we talked about supplementary angles, and I'm not going to draw a bunch of arcs because I don't want you to get confused. Maybe I'll put some dots. Well, that's not really going to help. 1 and 2, 3 and 4, 5 and 6, 7 and 8. 1 is supplementary to 2, 3 is supplementary to 4, 5 is so on and so forth. Then we look at this line. 7 and 5 are supplementary. 3 and 1 are supplementary. 8 and 6 are supplementary, and 4 and 2 are supplementary. And then when we did our alternate interior angles, so you could already see 4 and 5 are already both circled because they are congruent. And that means these two are congruent to each other, okay, because they're alternate interior. And we already said that same side interior angles are congruent. In other words, 3 and 5 are equal in their sum of 3 and 5 equals 180 degrees. Same thing for 4 and 6. Okay, but now we're talking about alternate exterior. I just kind of wanted to do a quick review. So when we think exterior now, I will stay with red. We're looking at these, and I'm going to put a little arrow here. The angles that are above and or below the parallel lines. Okay, here's my parallel lines. I know these are interior angles, so I'm not looking at these. Cross them off if you have to, so you don't get confused. We're looking at the ones on the outside. And it says that alternate exterior angles are congruent. So when I look at number one, and just like we did on the inside, when we're looking at the interior angles, this is on the upper left. So what is the alternate, or the opposite, the opposing position to upper left? Well, it's bottom right. So 1 and 8 are alternate exterior angles, and they are congruent, which means, here's number 2, this is on the upper right, okay? So the alternate or opposing position is the bottom left, okay? Which means 2 and 7 are congruent because they are alternate exterior angles. So we say alternate exterior angles. We have 2 sets, 1 and 8 and 2 and 7. Just like we had 2 sets of alternate interior angles, so now we're looking at exterior angles. Okay, and I don't know if you see what's taking shape here, but hopefully you will. We'll go put it all together here in just a few minutes. Okay, now hopefully that's okay. That one's not so bad. And then the last category we have is, let me make sure that's where the notes are going next. I'm pretty sure it is. Yeah. The last category is called corresponding angles. Corresponding angles. The corresponding angle theorem states that the corresponding angles created by a line crossing 2 parallel lines are congruent. Now, I think this one is probably the hardest to grasp because recognizing what they are is difficult when you say relative position and blah, blah, blah. But I think the way I explain it is probably as good as it's going to, as good as it gets. What do you mean by the same relative position? Okay. And that's the next part. The definition of corresponding angles is the angles that occupy the same relative position at each intersection or vertex where the transversal crosses the parallel lines. Okay, and I'm sure that's what it says next. Let me look. I actually have a set of notes here. Yeah. So crosses the, and then there's a blank, which you're going to write parallel, and then the word lines is already typed. Okay, so you're just going to go ahead and finish this out. All right. Corresponding angles are angles that occupy the same relative position at each intersection or vertex, because that's the same thing, an intersection or vertex, where the transversal crosses the parallel lines. So that means when we're trying to find corresponding angles, it might be wise to look at each vertex separately. And I'm going to show you what I mean by that. All right. So let's take a gander at it. So here we go. All right. Here is our angle representation. So we're talking about corresponding angles. So now it's all based on the 2 vertices. So remember, there's one here and there's one here in this drawing. Okay. And what I tell students to do, since I'm looking at each one, I'm going to kind of, now this is only for corresponding angles. Okay, this helps with corresponding angles, not really with anything else. All right. I'm going to kind of divide the drawing in half because when I look at this vertex, I say, well, this number one is in the upper left, number two is in the upper right position, number three is in the bottom left, and number four is in the bottom right. So I'm just labeling these angles according to where they are from the vertex or in reference to the vertex. But now I have another one down here and I say, okay, when I look at this vertex, this one, this is the upper left, and this is the upper right, and this is the bottom left, and this is the bottom right. And when I do it this way, it's clear that the two upper left angles are corresponding angles. They are in the same relative position to their vertex, to their local vertex, if you will. Okay, so that means they are congruent. And that means the two upper right are, and if you look at them, you can see it, right? Look at this angle. It is definitely an acute angle, right? So is this one, and it's the same acute angle. And I could prove it to you with a protractor, okay? Same thing, and we may do that next week, okay? Just so you know. And then this angle is clearly obtuse. And you look at this, and it is clearly obtuse. So this has to be true. And I circled them in different colors so you wouldn't get confused about what was congruent and what wasn't. Let's see. So the two bottom left angles are congruent. And we'll go with this lavender. The two bottom right angles are congruent. Okay. So now I have four more sets of congruent angles. All right. So now we've pretty much looked at everything. One thing I didn't mention, let me see if I mention it. I don't. So one thing I didn't really put in the notes is that's really it, guys. That's all, what, 5 categories? Supplementary angles, alternate interior, alternate exterior, vertical angles, and corresponding angles. Yeah, 5 categories of angles, okay? Now, and then we're going to practice some of it, and I'm going to show you some things that are really, really cool about these angles as we move forward. But one thing I haven't mentioned, well, actually, I'm going to move it, so give me a minute. I want to go back up here where we were talking about exterior angles. Okay, so we already said, we're going to back up just a little bit. We've already said that alternate exterior angles are congruent. So we know 1 and 8 are congruent, and we know that 2 and 7 are congruent. They're the same angle measure. And again, you can look at them and see that. Okay, now, just like with same side interior angles, their sum is one of their supplementary angles. Same, and you might want to write this down because I don't have it in the notes. Same side exterior angles are supplementary angles. So just like we have with the interior, we said 3 plus 5 equals 180, 4 plus 6 equals 100. So the measure of angle 7 plus the measure of angle 1 now, because we're looking at same side exterior angles. 1 and 7 are on the outside, they're exterior angles, and they're on the same side, which is the left of the transversal. So the measure of angle 7 plus the measure of angle 1 is equal to 180 degrees. And the same thing for 2 and 8. Okay? So I just want to throw that in there because that's something you may need to know or that you may use. Okay? And so now we're going to go back and we are going to create a complete list. Okay? We have 12. 12. This is the longest one. And before I do this, I am going to tell you that you will be required to do this on a quiz. You'll be given a blank chart and you need to fill it in. No, I don't want to do that. I'm trying to zoom out just a little bit. A little bit more. There we go. That's good enough. Okay. Because I want this column here. You have the papers in front of you, so it shouldn't be hard to see. Okay. So under supplementary, and I'm going to circle them as we go. Okay. Or, you know, for each category. So now the T at the end, this stands for alternate interior angle theorem. Okay. And that's how I've been doing it for years. That's fine. Um, so we're going to leave it like that. All right. So let's just start off with red. So supplementary angles, there are 12 pairs. So you might want to write a 12 in parentheses that commit that to memory. Okay. So I'm going to write 1 and 2, and then 3 and 4, 5 and 6, 7 and 8. So these two and these two, and then these two and these two. Okay. Now let's look at, so now we have to look at the other line, which is these two and these two and these two and these two. So looking at the ones that are circled by blue, you have 1 and 3, 2 and 4, 5 and 6, 7. I'm sorry. I already did 5 and 6. 1 and 3, 2 and 4. There we go. 5 and 7, and 6 and 8. There's 8 pair right there. Okay. Let's go to this brownish looking color. Then we said same side interior angles, which are these two on this side, and then these two on the other side, are supplementary angles. So that means 3 and 5 and 4 and 6 are supplementary angles. I'm going to have to use circles for the last category, and I'll use black since we haven't used that yet. And then we said same side exterior angles, so angle 1 and angle 8. I'm sorry, angle 7. They are supplementary angles. So 1 and 7, and we use a completely different color. Let's use this lavender color again. 8 and 2. Okay, that's it. That's all your supplementary, and there are 12 pair. Okay, you need to know that. Okay, all right. And you might want to make a note here too. The first 8 pair are straight angles. Or they're on straight angles. Okay, they're pretty easy to see. This pair are same side interior, I'm going to abbreviate, angles. And then these two pair are same side exterior angles. Okay, so that's where they all come from. Okay. All right, let's get rid of all this now. Oops, I mean, no, let's not do that. Let's get rid of, sorry about that. Let's get just rid of this stuff. There we go. Okay, so alternate interior angles. That's really easy, right? Because like I said, you build a house. We're looking at the inside angles, inside in between the parallel lines. Alternate mean opposing sides. So 3 and 6 are alternate interior angles, and 5 and 4 are also. So you got 3 and 4, and you got 5 and 6. That's it. Okay. Then you got alternate exterior angles. So let's use blue for one set. I probably should have used different colors for the last. I don't want to do that. Let's redo that. Let's use an eraser for that one. What in the world am I doing? Why did I write 3 and 4 and 5 and 6? That's crazy. I apologize. I don't know what I was thinking. It's 3 and 6 are alternate interior angles. My word. And then I just called it. And then in red, 4 and 5 are alternate interior angles. I think the 4 and 5 threw me off or something. I don't know. But anyway. Okay. Now, alternate exterior, we'll go to this brownish looking color. Again, exterior angles. So now we're looking at the ones on the outside here. Okay. The last 4 that we haven't looked at yet. So 1 is an exterior angle, and its alternate is 8. And then 7, well, let's use a different color. Use that lavender looking color. And then 7 is an alternate exterior angle to 2. They're both exterior angles and they're in opposing positions from each other. Okay? All right. So up here, we write 2 and 7 and 1 and 8. And that's it for those two. All right. So now we're going to look at the next category, which is corresponding angles. All right. So, well, before I do that, let's name the vertical angles first. And you can just draw lines through them. If they touch a line across from each other's vertex, then they're the same. So 1 and 4, and then 3 and 2, and 5 and 8. Well, I don't know what that was. 5 and, ooh, that looks awful. There we go. And 8, and 7 and 6. And done. Okay, there's only 4 sets. And there are only 4 sets of corresponding angles. But this one is where you take your time, okay? Draw your 2 vertices. There's one, and there's one. And go ahead and divide your parts into 2 parts. And label upper left, upper right, bottom left, bottom right, upper left, upper right, bottom left, bottom right. Now, once I've drawn that, okay, I take the two upper lefts, and they are congruent. These are all congruent angles except for supplementary, okay? That's where the sum is 180. But the rest of these are congruent angles. 1 and 5, 2 and 6, and 7 and 3, and then 8 and 4. And that's it. Okay. Now, we use these angles to solve problems. We've already seen some of that, okay? But that's all the angles that you need to know. And those of you in 8th period, you already saw where one of the 10th graders came in that I had a couple years ago. They're using these very relationships in geometry to prove that two triangles are congruent to each other, okay? So you will see this again. You need to know this, okay? But that's how you identify all your different types of angles, all right? And then we'll look at a special relationship that I call the Rice method um, next week. All right. Have a great weekend. See you guys on Monday.